Assalamu alaikum dear viewers, welcome to our YouTube channel Structure Design Experts. In this tutorial we will study about the basic use of Etab. If you are new here, if you not subscribed to our channel, please subscribe our channel for more updated videos. So in this video you will learn about how to use the different commands from the top bars. So now let's start, such as loads assignments, load combinations, and how to draw the columns, beams, slab. So first click on the Etab and go to this screen will be appear. So click file. If you have already model, so click on open and select the model and click on open, then it will be open. If you don't have, if you are new, so leave this one, cancel this one, go to new model. The first of all, use the user default setting is the setting which you have already saved. So it is not for a newcomers, it is for those who have already saved from the another. And this one is also like that, some files. So we will select this one, SI system, and the center in this two is for steel designing. So leave this one, and ACI 31814 is for our concrete. So okay. So now this is a grid data. If you have a uniform, so you use this one. If you don't have uniform, so you can use grid data. If you want to transfer the dimensions from the architecture drawings, so you select on the center, this one, grid data as spacing. So click on here. If you transfer from the drawing, so here you can write here for the transferring from architecture drawing. So suppose we have entered the value, suppose, and here the diagram is also showing here. This is the grid lines with the diagram shape. So here we, for example, we select 4 stories. How much story you have to design, you will enter here, but in the height is 4.20, and the bottom height means that it is up to ground level. It means that it is substructure. So 1.5 meter is our substructure up to tie beam level. And click on the grid only and blank. So this is the slabs, all the flat slab you are using, and the one is blank and one is grid line. So we use grid lines here. So now the window has been appeared. The one window is plane view, and the second is 3D views. So in file, you know that you can export different dimensions or drawings from the other you have already worked. If you don't have, so leave this one, you can print it, you can capture it. It is for multimedia, only for printing and such like that. So we will use here edit. It means that you work in the previous model, such as you designed the model and you want to make some changes, you edit. So now we don't have worked on this model, so we cannot work here in edit. So now we will define. The important thing for the new user is define. So we will use this one, define. This is the very important for newcomers, for beginners. So click on define material properties. First you have to know about the material, that which type of material we have to use. So the first material for the concrete, for example, for concrete we already have 4000 psi, so we select 5000 psi per square inch. For example, for the strength, it is the strength of the concrete, so you select them. I selected 5000 psi. For example, for more detail, you click here, modify and show material properties. So here it is, FC frame is 5000 psi, and the MPa 34.4 means 34 MPa megapascal. So, okay. So now if you want to Select the red bar concrete steel bars using is grade 16 is already I selected 17 grade steels. So here you can see that it is 5158. It is the yielding steel yielding strength and maximum minimum strength of the steel. So it's okay, we selected this. It is important to define it here. So now section properties. Now we have to frame section properties. Here is a lot of frames: steel I shape, steel O shape, I shape, L shape, etc. A lot of steels. But here we are using a rectangular, concrete rectangular. So we will be using concrete rectangular shape. So here already it is you can modify and show it also, but I want to add a new property. I need a rectangular. If you have want to select circular, you can, but I need a rectangular. We are mostly using rectangular. So here you enter the value. For example, this is for column, so write the column size. You can select here, and psi I already selected 4000. I just select 5000 psi, 4000 psi as you need it. So select the psi as like that. So now here you enter the dimensions of the column you supposed. So for example, I supposed 3 by 3 centimeter, 30 by 30 centimeter, 300 by 300 mm. Here is mm, so 300 by 300 mm. So modify and show. Here you select the columns, and here you can select the steels. Select the three dotted lines and select the steel grade. Here you can select the grade 75, 60 or 50 grade. I different as per your design. So now select the rectangular and the ties and this reinforced to be designed. So here is, you can say that the distance between the cover means the distance between two bars is 30, depend on your size of the column. So select the number of the steel, how much steel you are using, how much grade steel you can use here. So now add another like that. For beam, use the psi, the size of the beam. I use 600 depth and 300 width. I selected just for to modify and show. Here already selected column. So now we have to select the beam. So here the beam, for example, the top bars distance between two bars is 30 mm. Basically using sometime that a lot of steel, due to the huge load, we are suggesting 25 mm, but at least it is 30 mm. You can also select 40 mm to 60 mm, no problem. It depends on your design. The structure designer, you know about these things. So select the strength of the grade of the steel. Here also same, like you must have to design the column and beams. Already you think about that how much grade steel we have to use. So it is directed by the consultant or directed by the local authorities, that for G+1 we are using that type of steel, etc. So this is the detail. So already still different, you have to design different beams and columns. So the column section is completed, beam and column section. So now define, go to define again, section properties, and go to the slab section. This is per 2 per steel. So here is slab section. So this one is slab section, sorry, this one slab section. Select the slab one. You can modify it, no problem. If you modify, show and modify. If you add new, no problem. That is different on your data entry. So here you use 5000 psi for example, or 4000 is already. So it is slab 3 5000. We using 5000 psi. Shell thin or shell thick. So slab, it is slab, not a ripped or drift or ripped slab. So it is Okay, so the slab has been defined. So now is wall section. It is the wall section. For example, shear walls. It is basically per shear walls. So mostly when we design the shear walls, so mostly we use this type walls dimensions. Mm. You select the color for this. Okay. Now define the section. Go to the section properties. If you want to design anything, you should to design it. So now how to draw the column and beams. So go to the draw section, click on draw, and below is the draw adjoint objects, draw beams and columns. So here is, for example, this is quick beam. So here is also the sign present. So here you must to change the properties here. For example, we have already designed the beam, so I selected the designed beam. So already pre-designed beam also is present here, but you should select this one which you have designed. So here I selected one story, so one story has been assigned. So I selected the similar stories, the all stories will be assigned. So you have to select the similar stories. I select the similar stories, so all the beam assigned are drawn to all the stories. So you should to see about that. So here is the column, and the sign is column is also is here. So now the column, you change the properties of the column from there. It is very important to change the properties. Here is column 300 by 300. So I select the columns of concrete rectangular. So you see I selected the similar stories. So all the columns has been assigned to all the stories. So now you have to, the third section is the slab section. So go to draw floor walls objects, draw beam columns. So where we have to go, so these three sections is using after the complete, when you complete your design, after that these three are using. So now we use the draw and select and assigns objects. These three we will using before this during the work plan. So now we have to draw the slab. This is the draw walls and objects. So here is the beam, slab. So different type of slabs. So for example, I select this one. This one is how to draw the slab like that. I small points I select here. For example, I draw the small pieces of the slab for your learning. So this one is I draw a small piece. So see, this is to draw the slab. Sometimes you need to draw the slab like that. When you overhanging it, so it is I select overhanging type, that irregular shape. So now if you have to select in this one quick floor plan, so this one the sign is also here, but you see that you can select it one by one. You can select it one by one. So if the third, here you in properties you must enter the slab one. You select the slab one. It is very important, as I already told. So define now the third type of the slab for 3D walls, for 3D sections, for stairs ADC we mostly are using. So this one is just, it is, if you need this type, the length and dimension of the dimensions or thickness of the slab is same, so you can select first point, second point, and third and fourth, and go back to the point. So it will be considered a one section because the thickness of the slab is same, so it is consider one section. Like that, if you assign the load, when you are assigning load, it will be in one section. I will define it later. So now you assigned. So go to the story first. That is your first story. So we no need slab here. For example, I delete this slab. So select the slab, select the one story. If you want to delete the slab, so select one story. If you similar story, all the slab will be deleting. So select this one, select the slab, go to edit, delete. So the concerned slab has been deleted. That is the way how to delete. So click here and go to design, delete, edit and delete. So I delete this small point also. So go to, don't select the beam, I select the slab and go to edit and delete the slab section. So it has been deleted. This is the way how to delete. Go to the first story. Now we are in first story. You see that z is equal to 5.7. It means that in one first story. So now we have to define and draw. So now we have to use select. How we have to use select, and we are use this select button. So now check, go to click on select and select, go to object types, click on object type. So here is the beam, columns, floors, each and everything is here, but we select the floor because we assign the loads to the floor. Remember that self-weight Etab calculating when you define the material. So Etab calculating the self-weight of that materials. Like you select the materials and the size of the beam, so it is self-weight is being calculated. So you go to shear and uniform load. For example, shear load is for the slab you use shear load. So this dead load, for example, I suggest you 2 kilonewton per meter square. Apply. You see that the 4 different type of slab assign the loads, as we already told that this one section slab. So it is one section slab. 2 kilonewton has been assigned to one section, and this is different thicknesses. So 1, 2, 3 and it's different thicknesses, and 4 is the same thickness. So the same load has been applied on this point. If you have all the same, so you can sign. So now select again, enter the live load, enter 1.5 mortar load, select this add to existing load, because the mortar load is existing load, add with existing. So 2 was the did load and 1.5 is 3.5. So you should to remember this one also. Again select the floor and go to the shield loads. See, the frame load is for walls, so it's uniform. And here select the live load. For example, it is, I suggest 2.5. So the center point, replace existing loads and OK, apply and OK. See, 2.5 live load has been assigned to the floor. So delete this type of slab, we no need it, is just for learning. So I want to delete this. Select this similar stories and delete it, because it is was just for your learning. Select this piece of slab also too. So now if you want to select the object such as walls, So it will be selecting here, but if you select by the hands manually, it will be very good in fact, because sometimes you need walls somewhere. If you select all the walls, so it will be select all the walls, it is not good. Select by hands. For example, this one here no need walls, for example. And then select this one, here no need walls, here is not a wall. Where you selected, it is walls. Where you not selected, it is not wall, because if we select all the walls, so how we will be enter through the building. So you should to avoid up these things like that. So here is the way to entrance. So now frame loads, select the frame load, distribution load. So here enter 10.5 kg as per AC 710. So it is 10 kilonewton, 10.5 kilonewton per meter. So you see the load has been assigned to the wall load has been assigned to the structure. So you can see also in 3D. See here, you see that on the top of the roof it is too much, but you can reduce it. Delete from the top and add the parapet wall 1.70 or 80 meter. Sorry, 0.80 cm to 90 cm parapet wall. So here we selected it just for learning. So now this is analyze, you check the model. For checking the model, that what is the problem in the model, if there is a warning message or not. So this is display, or the display is silent, because we not run the analysis. It will be working after running the analysis. So now we have to move to how to use the load patterns. So it is very important. So go to load pattern. Here is the for example, we use earthquake load and x direction, y direction, as well wind load x direction and y direction. But here I just mentioning a one wind load, earthquake load, ACA 17 at, and now using wind load, here select the wind and as per AC 17, for example, at now we use the snow load. If you are in that snow area, you should select the snow. If you don't have the snow, so you leave this. And the rain and other loads, you should to include it in the life load. So because some area local authorities, society of engineers directing you that the rainwater load is including in the life load, so it was a specific amount of load. So now you go to define, it is the diaphragm. When you not assign diaphragm, so you cannot calculate the wind load. The diaphragm for the wind load is very important. First you have to select the diaphragm, and after that you have to load. Here we just first we already we assigned the load, so here is not present. So you see that the diaphragm not calculated the load, so it is not good, because first we have to draw the diaphragm. Go to the define the diaphragm. Here you define the diaphragm, okay, and then go to assign shell. Different things is here, but you have to select the diaphragm. Stiffness modifier, thickness of etc. But here is diaphragm. I select D1. Before diaphragm, you have to select the splores. Go to select menu Before clicking OK, you have to select the floors. So now select the floors. Floor has been selected, and now select the diaphragm. So assigned, the diaphragm has been assigned, so you can see on 3D. Here in first floor, here is floor, the diaphragm has been assigned, so you can see also in 3D view. So delete this one just for your learning. See, here the diaphragm has been assigned. So now you have go to the load pattern, wind load. Before we checked, there was no load calculated by the diaphragm. So now you see here is no load, same like before. We have to delete this one again. After the diaphragm, you have to enter the wind load. Delete this one and enter the wind load again. So it will already calculated by the diaphragm. It will be showing here. So wind load SC17. Click on add. Click on the add button. Okay. So now you okay. Now you go to load pattern. Define load pattern and click on the wind load modify and show. So here you see modify and show. So you see that here the diaphragm calculated the height of your building as well width, x coordinate and y coordinates. So it is very important to use diaphragm before you adding the load of winds. So now mass source, add new mass source or modify or show existing. So add dead load is 1 and add 0.50. Basically we are according to ASC 17 we adding the 5%, 50% of live load of the dead load. So it is just an example. You can use any standard, you should to use the load. So but the actual load we are using according to AC 7010 is 0.50. So if the height of the building, the stories is less than 10 stories, so we using 0.25 to 0.30, or if the more than 10 stories, so it is must be 0.50. So we add the mass source 2 as before. The mass source 1 is the same load already present, so but let's see. So now you see the define the other like load cases. So it is the load cases, dead load, live load, and it is all the static positions. So no load combination, add new load combination according to your standard. But if you want to use the default setting calculated by the Etab, so use the concrete frame design. For concrete frame design, beam and columns. So it is beam and column. Frame design means column and beams. So here is calculated 1.4 plus 1.4, and the second combination is 1.4 plus 0.6, etc. So you can use any standard of international standard, ASC or BSR, Indian standard, Australian standard, anyone, and if you want you can select it. So it is the working vibration. You should use working vibration for the your stories. So here you should to add the load according to your standard as per the ACC 07010 7-10 or BS1 81165. Now we checking the model. So check the model. Wait while the model is checking. Check model again. because the one was not responding. Wait until the model has been checked. No warning message has been found. So model is ready. So now run the analysis. Run the analysis means that before run the analysis you should to save the model. Run the analysis means that all the loads, combinations loads and you entered should be calculating. So check it. Now the run analysis has been completed. You see that now you can click any corner of the model. You will see the displacement, base reactions and displacement. Now you these three has been completed. As we already said that now we will use display and design option. So now this is the maximum displacement of the stories. So you can check any one. All the stories already selected and per dead load it is the displacement. Now we select the earthquake load. So there is no displacement against earthquake load. So now other loads, snow loads. So there is displacement 0.17 against the snow load. So any one load if you want to select, you will see the displacement of the story. So now we will check the go to display and energy in virtual diagram. It is as will. If you want to go to display, see the deformed shape and other shape like that. So it is the concrete frame design. So you should to click here is also present, but if you want to click here, so view the preference. So it is the preferences of the design. You should to check it. Now you can start design check that how is your design. So go to design and go click there concrete frame design and click on the start design check. When you click on start design check, they will check the columns and beam one by one like that. You yellow line showing here that it is checking one by one. So now you see that the model has been checked. See the plane, click on the plane first story or second story, anyone you want. So if you click right click on any one beam or column, you will see. But now verify all the design check is passed. So 30 concrete members has been failed. So you see in 3D that 30 members has been failed. So you see in the dotted line, this is the failed members. Anyone you click right click here, you will see the detail. Now it is detail. You see that this is your beam. So why the beam is failed? So overwrite, if you want to overwrite here is to click current design section. So it is the current design section. If you want to change the design section, you have already added one type of beam. You should to add the lot of type of beam. If your one beam has been failed, so from this point you can change the size, so it will be become fast. So that was your design check. Now go to design, this is for the shear wall. If you design shear wall, so already this will be appears. So now go to the design. This is for live load reductions, and so here you can click on this diagram or go to display and click on this, so you can see the shear force and bending moment diagrams. And this is a design, this is the slab design, live load reductions, lateral displacements, time, it's the detailing here, which just checking the detailing. So that is the detail of RCC. So here is the detail. If you want to change it here, so enter the values here, and it is the diagram of the beam. So it is the single span, it is the single span, and it is the double span and multi span diagram of the beam, that how your design will be. So you can now we detailing for calculating the frame. So here is your warning messages. Here if there is no warning message, because our 36 members has failed, so therefore this is the warning message that you should to review your failed members. So unable to generate the detailing. If your the building your wall is passed, your frame is passed, verify that your frame has been passed, so then you can click on this diagram and check the shear force and bending moment diagram. So here is the shear 3 you will see that here is the fail column. You show that in the red line is showing that it cannot transfer the load easily. This is the shear, you see that shear is okay almost, and that is the combination, load combo. And you combo 1 is, for example, combo 2, combo 3, you can check it that there is not too much difference. And load cases is generally live load, earthquake load, snow load, and other loads. Wind loads, for example here is the wind load, it is very safe against wind load. So now you check the base reactions. Here is base reaction, you see apply the base reaction showing like that. So click on tabulated form, see that the base reaction, it is the base reaction. If you want to see only the base reactions, which is very important, so it is the base reaction. From this base reaction you can calculate the you will be able to calculate the footing for your building. Now you can see our dead load, that how much was the dead load. So here is the dead load 3.5, and live load is not showing here, but it is the dead load is showing here by this way. If you click there, so it is the undeformed shape without loads and without edge, everything is the undeformed shape. We want to change the database, edit the file and the showing. So it is the database. Anyway, if you want to change the color of your floor beams, links, springs, tendons, etc., anyone you want, you can change from here. Select the ESC escape button to go to deform shape. Click option, see that auto save model, save the user default setting. That is the default setting, user default setting here successfully saved. And before we starting, we say that three options. There were three options: user default setting, save setting from models, and user. So we selected user. If we want to save this from this model and want to open the other model, so the loads, the dimensions, the materials you edit will be no need to redefine, so it will be automatically present, so it will be present from this model. So therefore you should to user, if you want to use a save user default setting, save user default setting. Once you create materials, once you create loads, assign loads such as live load, load combinations, mass source, age, and everything, it will be automatically saved, and in next model you can use it, so it will be very easy for you. From the table you can also see your reports, such as base reactions. Right click there, show table, so you will see the base reactions. So that is your base reaction. Definition data, summary data, and concrete frame design data. So all the information you can collect from the reports. So click on the reports. Now you see the summary report and project report. So we want to watch the project report. Wait until it is opening. It is more than 200 pages. All the loads you calculated, it will be showing here. You see, this is the complete report. Click on any one of these, you will see the detailed report. So the report is waiting for to generate. So now it is the your Etab report. It is the latest version of Etab 18. You see that, see it is more, it is total of 242 pages. You see 242 pages report. How to design the vents load, how diaphragm calculated the loads, all the things are present here. Load combinations, how the Etab calculated the different type of loads. So it is the detailed report. I think it is enough for our new beginners. So if you not subscribe our channel, please subscribe the channel before you leave it, because we are updating our new videos, making new videos regarding Etab. We are professionals, because if you want to learn more about Etab, such as story drift and story displacement, the link of story drift, story displacement is already given in the description. So you must visit if you want to watch the complete project design, that how to calculate the load. It is very important for beginners. Once you watch the complete report, complete project designing, so you will learn about that how to design it. Thank you for watching. Have a